In April of 2009, the SuperTec Building Design and Engineering Technology Research Center was created as a part of research development in Ministry of Land, Infrastructure and Transport to push towards technological independence in the area of SuperTec building design and engineering. In these slides, 5 years of research results will be presented. The research managing organization of the SuperTec Building Design and Engineering Technology Research Center is Tangug University. The center is led by Lan Chung, professor of Tangug University, and consists of about 50 chief-level researchers. The total research period is 6 years, and total research funds is approximately $47 million, and out of the total research funds, $32 million has been contributed by the government. Now let me introduce the members of our research center. In 2011, the research center was reorganized from a research consortium to a research center, which consists of the advisory committee, steering committee, and research management team. The 4 research teams are researching the developments of an atypical integrated design system, technology to improve structural performance, technologies to improve the performance of structural systems, and smart sustainable management technology. The objectives of our research center are to find a larger market abroad while pursuing the technological independence of complex technologies in sustainable SuperTec buildings and IT integrated technologies. In order to achieve the goals, first, 3 world-class essential technologies need to be developed. Second, world-class ability in element technology integrated with cutting-edge IT should be secured. Lastly, international commercialization of SuperTec building technologies need to be achieved. The overall process of research can be summarized as follows. Currently, pilot tests of the SuperTec building element technologies are being executed in Korea, Mongolia, United States, Russia, Saudi Arabia, China, Qatar, and Indonesia. Our center is constantly making an effort to commercialize and expand out overseas market. Here is our major research outcome. We have achieved 572 research outcomes, and approximately 70% of the total outcomes were achieved in the 4th and 5th year. In the beginning of the research, the academic achievement rate was very high, but now it is in the practical use stage where we see a steady increase in outcomes such as patents of structure and construction method of diagrid steel joint and complex vibration control. At the end of the research, world-leading technologies in SuperTec building design engineering is expected. Here are some examples of domestic and international pilot tests in which we see practical use of the technology developed in our research team. Our technology in SuperTec building design engineering has demonstrated its superiority in 10 different countries and created $4 million in sales. The intelligent facility management system that have been currently installed to the Seasons building in Indonesia has been scheduled to be installed in many more SuperTec buildings, and hopefully this will bring out more sales of this technology. First of all, this side shows design optimization technologies of atypical structural systems. These technologies contain the Seismic Performance Evaluation and Modeling Automation Process (EQ Auto) and a Joint Performance Evaluation Modeling Automation Process (CON Auto). Both technologies were used on the 190-meter-high MAC tower to obtain as much detail as possible on seismic structural performance and large-scale beam column joints. It also created an opportunity to export 6 tons of domestic structural steel. Moreover, outrigger joint detail design was performed on the 555-meter-high Lotte World Tower, which will be the tallest building in Korea once completed. In other words, detailed design of complex structural parameters took approximately 70% less time by using the ConAuto application. The optimal decision was automatically made from a variety of alternatives proposed by the ConAuto. This is a data processing platform of an atypical integrated design. Currently, this technology is being applied internationally on large-scale projects. The technology was applied on the 283-meter-high M Tower for optimizing the cross-section size and concrete strength of columns in the SuperTec building. Total structural frame cost was reduced by 13% by repetitively analyzing thousands of propositions. The next example is United Square of International Capital Trading in Abu Dhabi. $3 million was saved in the construction by optimizing rebar detail design, load design, concrete strength, and rebar strength. The next technology is an in-situ multifunctional cooling and heating panel system for SuperTec office buildings, and this technology was applied on the J. Platz building in Seoul. The developed system can provide better quality cooling and heating performance by combining lightweight aluminum panel and radiant board. Compared to the previous cooling and heating system, it has been verified that this technology reduces energy consumption by 18%. The next technology is wind vibration mitigation. Active mass damper technology was secured for a solution for the resonant phenomenon Technomart 21 building incident, which happened in 2011. The world's first vertical and horizontal vibration control device was developed and manufactured for a capacity of 50 tons. A performance test was executed for vertical and horizontal vibrations in 2013. With recognition of the superiority of developed technology, we manufactured and installed vibration control devices on an airport control tower in the third stage of Incheon Airport, and we are currently in the process of an additional pilot test. The next technology is an intellectual management technology. This technology was applied to the 33-story high residential and commercial complex building in Jakarta, Indonesia. A $1 million 5-month contract was made for construction of the smart building. Currently, we are in the stage of applying a smart building solution based on the integrated management technology. I would like to introduce some of the news reports in broadcast media and press that explain the development process, results, and the social and economical ripple effect of our developed technology. One of the 4 major daily newspapers and public broadcasting reported that the vibration control device from the National Research and Development Project has relieved nationwide anxiety resulting from the Technomart 21 building vibration incident. It is one of the successful cases of applying the National Research and Development results, which was a big opportunity to showcase our excellent results.
이 제진 장치는 한국건설교통기술평가원의 초고층 설계기술연구단이 연구 개발에 상용화에 성공했는데요.
Every year, the National Science and Technology Commission selects excellent results for improving the understanding of science technology and inspiring self-confidence. In 2012, Strato Optimal Design Technology for SuperTec building from an atypical integrated design program was selected as an excellent result of government-supported research and development. In 2014, our research team that developed the technology for performance improvements of structural systems accomplished the splendid feat of winning the 100 Excellent Results Award with their wind-induced vibration control device technology. The National Academy of Engineering of Korea, which is a group of renowned scholars and industry CEOs, published reports of science technology and industry performance for the past year. Our vibration technology device was selected, and it was the only technology from the architectural field in 2012. Also, a design optimization technology for a typical structural system was selected in 2014. For practical use of our developed technology, the development of superior technology, commercialization of developed technology, and strategic marketing promotion are needed. Public Broadcasting introduced our technology in the Mac Tower with the title of K-Build Craze in Mongolia. It gave us an opportunity to promote our excellent design technology from Korea in the super tall building design engineering market, which is currently led by big overseas companies.
몽골의 초고층 건축물 건설을 계기로 우리나라 초고층 건축 설계 및 시공 기술 그리고 자재의 우수성이 세계적으로 알려질 수 있고 우리나라 건축 한류 확산에 큰 도움이 될 것으로 기대합니다.
In addition, our research center was evaluated as a company with some of the best technology in the field of land, infrastructure, and transport. As a result, Jung-ho Kim, the head chief of Changminu Structural Consultant, received an award from the Ministry of Land, Infrastructure, and Transport. Here, many of our achievements for the past 5 years have been briefly introduced. Our research center will always actively support and make an effort to secure the world's best super tall building design engineering technology. Our technology makes your dreams come true. Just imagine, it comes true with our technologies.